Hi, my name is Gabe Adams, and I am a senior in electrical engineering.
My name is Vance Weiberg.
Hey, this is Ryan Esmery.
Hi, I'm Michael Darnell.
Hello, my name is Alexis Ayala, and I'm a senior at ASU studying electrical engineering. Today, I'll be introducing to you our project, Open Source ASIC Design and Nonlinear Sampling. The goal of our project was to design, simulate, and prototype a custom 8-bit SAR analog-to-digital converter while using entirely open source tools. We wanted to show that IC development, which is something that's traditionally reserved for large companies, can be made accessible to individuals such as students, researchers, or even small startups. Our project revolves around using free software such as Icarus Verilog, KiCad, Python, and more to handle everything from simulation and design to physical modeling. We chose to design a SAR ADC because it's an essential part in mixed signal systems and allows us to demonstrate both digital design and applied real-time signal processing. We're excited to show the capabilities of these open source hardware tools and to help contribute to the growing movement of democratizing IC chip design.
Tiny Tapeout is this service set up by a guy named Matt Venn that allows for hobbyists and students to come together and get their own ASIC, their own application-specific integrated circuit board printed. Normally, a singular wafer has, so many thousands of different ASICs on it, and the company needs to test and make sure all the stuff's going to work on it, and eventually send that off to get printed, and it costs a lot of money. Well, what Tiny Tapeout does is it brings together a bunch of hobbyists and people who want to get an ASIC printed, and allows them to get together onto the same wafer, and then they send that wafer off to get printed, and everyone can get their individual ASICs.
Unfortunately, due to the closing of eFabless, Tiny Tapeout's manufacturing partner, we are not going to be able to have a successfully delivered Tiny Tapeout this year. But luckily, all along, we've been planning to have an Arduino stand-in for the SAR. This is our final circuit right here, which we will talk more about. But here is the SAR, and here is the output DAC, and then our R2R resistor array is up here.
So this is our block diagram for the hardware circuit that we have created. This was made in KiCad, and this is an open source software. So the analog audio is passed into this R2R DAC, which is then sampled by the Arduino using nonlinear sampling techniques to create the digital output. There's a feedback loop here to make sure that the sampled signal is actually matching on the digital output. So that's the purpose of the feedback loop. And then once that matches, there's another DAC over here, then takes that digital output and converts it back into an analog audio signal so that you can play it out on a speaker and check your sampling from the Arduino.
Successfully designed a Python code that simulates different signals, behaviors, and visuals. It also compares linear and nonlinear sampling. We also have the code recorded in audio, reads the file, and then analyzes it and give us a good output results. For the first plot, we have signal amp over time for all the type of signals. The second one, the error. The third one is curves of both nonlinear, comparing both. And that's pretty much is the code.